Okay, number one on the review. At age 20, someone puts money in an IRA. Here is our interest rate, and they're putting 85 in every month till they're 65. So we are going to use the Annuities Formula, and we're looking for the total amount at the end. So we're going to use the A equals the payment multiplied by 1 plus the rate over the number of installments raised to the NT minus 1, and then all of that is going to be over the rate divided by the number of payments each year. So when you plug this into your calculator, be really careful. You're welcome to use the app's finance program on your calculator as well. But if you're plugging it in, whatever version of the calculator that you have, you've just got to make sure that you put brackets or parentheses wherever you see them. So when I type this in, as long as I put another parenthesis where this bracket's at, I'm going to get the right answer. So we're not going to go through the math on all of these, but on this one, it's 85, and then there's a parenthesis. It's a bracket, but I'm going to use a parenthesis that does the same thing, and then another one, and then 1 plus. We've got another fraction here, and our interest rate is 0.06. And we're putting money in every month. So I divide by 12, and that's going to be raised to the 12 times a year multiplied by the number of years. So he's going from 20 to 65. So that's going to be 45 years. Then I've got a minus 1. And don't forget to put the nice thing about the TI-84 is, and I think the TI-30 is, it puts these bigger brackets if you have smaller brackets on the inside, so you can tell what they go to. And then on the bottom, we have another fraction, which is just our interest rate on top and our number of installments on the bottom. So when I hit enter, I'm going to get 234,259. And here's where a lot of you missed questions on the last test. Don't round until the final answer. And when you do, round to the nearest cent. So this 0.372 rounds to 37 cents. So be really careful with your rounding. I hate for you to miss questions on the test because of that. And then it asks how much of that money is from the actual deposits. Well, if I deposit $85 every month for 65 years, or not 65 years, 45 years, then that is the amount from deposits is 45,900. So I just multiplied how much I actually deposited. The rest of that money is all coming from interest. And that's a great interest rate. That if you could get something like that set up, you'd be in a good spot. Number 2, use the saving plans formula. Your goal is to create a college fund for your kids. Suppose you have a fund, a 6% APR. How much do you need to deposit so that you can have $82,000 in 14 years? So we're basically using the same formula, but this time we are looking for P. And so remember, all of this gets moved to the other side, and it gives us a different formula where we're finding the payment instead of the total amount. So this is the one where you get the total amount times R over N divided by, what are we going to have? 1 plus, that's probably in parentheses, R over N raised to the NT, and then we need to minus 1. So again, when you put this in your calculator, make sure it looks the same. Make sure you use the brackets and parentheses where it's appropriate. You can also use the app's finance solver on this one. It gives you the N. So that's every month you're going to be investing money. Your interest rate is 0.06. It gives you, right now you don't have any money there. We're looking for the payment, so that stays 0. We want it to add up to be 82,000 when we're done. And then we're going to put 12 because we're making investments every, well, I guess our N is going, so we're going to be doing this once a month. And then our N up here, we need to do 12. Oh my gosh, 12 times 14. That's got to be our total payments. And then here's where we put how many payments per year. So then I go down to payment amount, hit alpha, enter, and it tells me that I'm going to be paying $486 a month. Oh, nope, that's not right because our interest rate needs to just be 6. Remember, on the calculator, it's going to say that looks a little bit high. Don't use the decimal, just use the regular interest. And now when I hit alpha enter, that looks a lot better, $312. And again, round carefully, please. This 6.613 rounds to 0.61. Don't miss this question because of rounding. Okay, number 3, compute the total and annual returns on the described investment. So 6 years after buying 150 shares at $50 per share, you sell the stock for $11,500. The total return is, so I spend $50 per share and I buy 150 shares. So I spent that's going to be $7,500 was my initial investment. And 6 years later, I sell it for $11,500. So it wants to know, what is my percent? Careful of that percent sign. What's my percent on my total return? So I'm going to use that formula to find my return, where we take the old, or excuse me, we're going to take the new, we're going to minus the old and divide by the old. Okay. So I'm going to take, and we'll just go ahead and do it right here on the calculator. I'm going to take the new, which is 11,500. I'm going to minus the old, how much I invested, and then I'm going to divide by that old amount. And that tells me that my total return is I increased 53.3%, because it tells me to round to 1 decimal place. So in total, I increased 53.3%, which sounds right, because 4,000 is about a little more than half of 7,500. The annual return, remember, I just have to figure out if this is my total return. If I just divide that by 6, I get my annual return, which is going to be 8.8% is going to be my percent that I get back, that I'm getting each year. Okay. So when I look at that, it's not just going to want the flat percent each year, because this is actually growing exponentially. So this is where we need to use, and I don't think it's on your formula sheet. We'll make sure to add it. The annual percent growth, because you have to derive that exponential growth. It was something like A over P, and it was raised to the 1 over the number of years minus 1. I believe is the formula. And I'll double check before we put the video out. So what I'm doing is the A is the amount that you have now. So I would put the 11,500 on top. I'm going to divide that by the 7,500, my initial investment. And I'm going to raise that to 1 over the number of years, 6 years. And then I've got a minus 1. So we're going to take 11,500 and we're going to divide that by 7,500. And raise it to the 1 divided by 6. And then I'm going to minus 1. So when I do that, it gives me 7.3%, which sounds, let's see, how does it want us to round it? Round to 1 decimal place. So 7.3, that's actually, that 8's going to round it up to 7.4%. So what's happening is every year it's growing a little bit of a percent. And then it's growing, that percent that it grows each year is included in its total growth. So we can't just divide by that 6 that we initially were going to. You have to keep in mind that there's that exponential growth, okay? So number 4, same idea. What's your total return and annual? This one, though, we're actually losing money. So we can expect some negatives here, but we go through the same process. To find the total return, we take our new amount, which is 2,500, and we minus our old amount, the 3,900, and then we're going to divide by our old 3,900. So let's do 2,500 minus 3,900, enter, divide by 3,900. And that's telling me that I am decreasing 35.89, and it wants us to round to the 10th, so 35.9%. And we would put the negative in front. The total return is a negative 35.9%. If it had said it's a decrease, you wouldn't have to put the negative. But because we're going down, it's a negative percent because we're losing money. And then the annual return, we're going to use that same formula. We're going to put the 2,500 on top. We're going to put the 3,900 on the bottom, and we're going to raise that to the, let's see, this is over 2 years. So 1 over 2 minus 1. So we're going to do 2,500 divided by 3,900. I'm going to hit enter, and then I'm going to raise that to the 0.5. I'm going to hit enter, and then I'm going to minus 1. So that means that each year I'm going down 19.9. If it's easier for you to times this by 100 to see that as a percent, you can. We're going down 19.9, which is going to have it round us to the nearest tenth. So again, this time we're at 20%, okay? Negative 20.0 or just negative 20% is how much you're losing each year. Okay, number 5, consider the following loan. Someone borrows $85,000 at 5% interest, and it's going to be paid off with monthly payments of $578 for 19 years. Identify the amount borrowed. So they borrowed $85,000. The interest rate is 5%. The number of payments per year is monthly, so that's 12 payments per year. The loan term is for 19 years, and the payment amount is $578. So how many total payments does the loan require? Well, if I'm paying every month for 19 years, that's just 12 times 19. So that's 228 payments towards the loan. And the total amount that's going to get paid, I'm going to make 228 payments of $578. So I'm going to times those together. So the total amount that I'm going to pay is, or this person, I don't want to say I don't want to pay that money, $131,784 is the total amount that's going to get paid. Of that total amount, what percentage is paid towards the principal and what percentage is paid towards the interest? All right, well, the principal amount is $85,000. So that one's easy to find because I just take $85,000 divided by the total amount, because I want to know how much is the principal of the total. So if I do the 85,000 divided by 131,784, that gives me 64.4. And again, if you need to times it by 100 to make it easier to see the percent, 64.49, and it tells me to round to the nearest tenth. So that's going to be 64.5% goes towards the principal, which means the rest goes towards the interest. So if I just minus 100, that tells me 35.5. So 35.5%, or you could put the rest of the amount over the total and get the same answer, okay? Okay, number 6, consider the student loan, $25,000 at a fixed APR for 15 years. Calculate the monthly payment. So it gives me the loan amount, it gives me the interest rate, and it gives me the number of years that it's going to take to pay off. So we use that payment formula for amortizations, and it's P times the R over N all over bracket 1 minus parenthesis 1 plus R over N, close parenthesis, negative N to the negative raised to the negative NT, close bracket. So you can plug that information in to figure out what your monthly payment would be, or you can always use the application, the finance app there. This first one, we'll go ahead and plug it in. Actually, you know what? I'm not. This video is going to get long. So you plug these numbers into the formula. The 25,000, that's your principal. That's your P. The R is your rate. Make sure you put it in as 0.09. N is going to be 12 because you're making monthly payments. And the T, time, is going to be 15. So when you plug those in, let's see, your monthly payment is going to come out to be $253.57 when you round it, right? Round to the nearest cent. So $253.57. The total payment, so I'm going to make that payment $253.57. So $253.57. I'm going to make that payment, every month for 15 years. So times 12 times 15. So that's going to be $45,642. $45,642.60. Again, round to the nearest cent. Of the total payment over the term, what percent is paid towards the principal and what percent is paid toward the interest? Well, the principal was $25,000, so you would divide by the total amount that you paid, and that's going to give you 54.8%, which means the rest goes towards interest. So the rest of that's going to be 45.2%. All right, number 7. Suppose on January 1st, you have a balance of $5,900 on a credit card. Your APR is 17%. You want to pay it off in a year. So that's 12 payments, right, in 1 year. Assume that you make no additional charges. What are your monthly payments going to be? So you're going to use that information and plug it right back into the same formula up here. We're looking for the payment. Our balance, the P, is $5,900. Our APR is 17% or 0.17. That's our R. T is 1 year. N is the 12 monthly payments that we make each year. So you're going to plug that in to get your payment amount, and you're going to get $538.11. Again, I don't want you to have to sit through me plugging it in the calculator. Just make sure that you use parentheses and brackets and that your picture looks like this. Okay? The total paid since January 1st. So the total amount that you're going to pay, if you take this and times it by 12, that's going to give you the total amount that you're paying, which is $6,457.32. Again, round to the nearest cent. So you're taking the monthly payments, you're timesing it by 12 to get the amount that you're going to pay in that year. The percentage of the total paid, that is interest. Okay, so if I paid $6,457.32, but $5,900 of that was the money that I owed, whatever's left over is the amount that went to interest. So I can do 6,457.32 minus 5,900. So that means that $557.32 went to interest out of $6,457.32 worth of payments. So the amount that went towards interest is 8.6%. So the amount of my money that I paid that didn't go to my total, the interest amount was 8.6%. Okay, moving on. Number 8, you need a loan of $130,000 to buy a home. Calculate your monthly payments and total closing costs for each choice below. So we're going to use that same payment formula. Okay, we're going to still use the PMT equals P times R over N, in case you didn't watch the last couple questions. And then on the bottom, you have a bracket, 1 minus parenthesis 1 plus R over N raised to the negative NT. And then we'll close the bracket. Whether you put this in the apps finance solver or you plug this information into the formula, either way, your interest rate is right here. The closing costs you're going to add after. The $130,000 is your principal that you're borrowing, and it tells you how many years you'll be making payments. And just assume that you make monthly payments. Oh, it tells you right here. You're making monthly payments. So I'm going to use the app solver for this one. And my number of payments, I'm going to make 12 payments for 30 years. My interest rate is 5%. My present value Right now I owe 100, or I'm borrowing 130,000, right? 1, 2, 3. I'm looking for my payment. I want my future value to be 0. So my payments, when I hit alpha enter, my payments are going to be $697 and 0.868, and it says to round to the nearest cent, so 0.87 cents. Now, if I do the same thing for choice number 2, if I lower my interest rate, then my monthly payment's probably going to go down. And when I plug that in, I end up with $658.69. The total closing cost for my first choice is $2,400. It tells you right there. The closing cost for choice 2 is $2,400, plus I have to add 2 points. And remember that what 2 points means is each point is 1% of the amount that you borrowed. So 2 points means I need to take the amount that I borrowed and times it by 0.02. 2 points is 2%. So that's going to be $2,600. So the closing cost for choice 2 is the $2,400 plus the $2,600, which is $5,000. Then you have to decide why might choice 1 be better, okay? The payments are a little bit higher, but up front, you don't have to pay as much money. So the closing costs are lower up front. Maybe you don't have as much cash to put into the house up front. And choice 2 might be better because your monthly payment is lower, right? You're paying $50 a month less, well, $40 a month less, but you're paying $40 less a month every month for 30 years. So you're paying $14,000 less in the long run because your monthly payment's a little bit cheaper. Okay. Number 9, a woman earned wages of $53,300. She received $2,300 in interest, contributed $3,800 to a tax retirement plan. She was entitled to a personal exemption and has deductions. Find her gross income. So remember, gross income is all of her income added together. So $53,300 plus $2,300 is $55,600 because she got $53,000 in wages and $2,300 in interest. She contributed $3,800 to a retirement plan. So her gross income, I would minus that $3,800. And so you can do that. Just go ahead, use a normal calculator. You just take the amount, her gross income, and you minus her retirement investment. So her adjusted gross income is $51,800. Her taxable amount, you have to minus exemptions and deductions. So you're going to take her gross income and you're going to minus $3,500, and you're going to minus the $5,040 from her deductions. So her taxable income is $43,260 would be her total taxable income. Okay, number 10. Same idea, exactly what we just did in the last one. So I'm going to actually let you work through that one on your own. Remember, gross income is everything in red. To get her adjusted gross income, you minus what is in blue. You minus what, whoops, I better be careful, minus what she put into a retirement plan. And to get her taxable income, then you minus her exemptions and her deductions. Other than that, it's the same problem, just new numbers. So if you have a question about number 10, go back and watch number 9. Number 11, decide whether a person should itemize or take the standard deduction. Now remember, you can only pick one or the other. You can either itemize your deductions or you can take the standard. So the goal is to figure out which one is more. So this person's deductible expenses are $8,100 for interest in their home, $2,900 for contributions to a charity, and $620 in income taxes. Or she can have a standard deduction of $11,400. So we just add these together, $8,100 plus $2,900 plus $620 gives you a total of $11,620. So itemizing their deductions, they get a little bit more of a tax break, okay? As long as we use the right numbers, right? 8,100, 2,900. Yep. So he, she, they, whoever should itemize because it would deduct more money from their income. So you choose D. Consider the following choices between paying rent and making a house payment. And when you're considering the mortgage interest deduction, decide which one is greater, the monthly rent or the monthly house payments. So if a person, we know they're in the 33% tax bracket, the apartment is $1,200 per month. Mortgage is $1,800 a month. But $1,500 of that is interest, which is tax deductible. So every year, or I guess for the year, they make 12 payments, and of that payment amount, $1,500 is interest. So that's a total of $18,000 in interest that year. This is tax deductible, but not all of it. You only get the 30, well, it is all tax deductible, but it doesn't take $18,000 off of your taxes. It lowers it that 33%. So what I want to know is, am I going to save more in my tax break than I'm going to save in my rent? So I take that 18,000 and I times it by 0.33, and you're going to get 6,000 or close to it. So $5,940. So that is how much I'm saving from on my taxes in my mortgage. So these are my savings. And there's a few ways to do it. You can take your mortgage payments, times it by 12, add it to this, and do the same with the apartment, or which we might as well just do. So if I take that 5,940 and let's add, I've got to add 1,800, but I have to times that by 12. I'm not adding it. I want to subtract it. Sorry. So we do 1,800 times that. Nope. Times by 12. So this is how much I pay in mortgage, but 5,940 of that I get in tax savings. So I really am only paying a total of 15,660 that year. My rent would be 1,200 times 12, which is just going to be 14,400 total. So even though I'm getting this great big tax break, the apartment is still less of a payment than it is to mortgage. So it's still cheaper to rent because the difference between the mortgage and the deduction is greater than the monthly rent. So we're going to choose choice B for that one. Okay, moving on. A recent telephone poll of 999 randomly selected adults revealed that 9 in 10 believe there has been progress in finding a cure for cancer. Describe the population, sample parameters, and sample statistics. So, population is all of the adults in the country. That's the population that we're interested in. The sample that they took are 999 adults that they randomly select. Okay, they didn't ask 9 out of 10. They didn't ask 9 out of 10 of the 999. They asked 999 adults. Identify the population parameter. So what it's looking for is, do we believe there's progress in finding a cure for cancer? So they're not asking everyone. We're looking at the percentage of adults in the country who believe there has been progress. Well, sorry, this is the population parameter. We are looking at everyone. The sample statistic is, out of those 999, how many believed that was true? And it tells us that 9 out of 10 do. So our sample statistic is 9 out of 10. Okay, 14. In a test of the effectiveness of garlic for lowering cholesterol, 48 adult men were treated with garlic. Cholesterol levels were measured before and after. the changes in their levels of LDL have an average mean. Identify the sample. Wow, that's a lot of jargon. So identify the sample. That's just the 48 adult men that were in the study. That is our sample. The population is all adult men. Okay. The population is all the adult men in, are they looking at all adult men? Yes. It doesn't say anything about a specific place or age or anything else. Identify the sample statistic in the study. So what does the study say? And it says that the average change in the levels of LDL were 3.4. That's what the statistic that we got from the sample is. The population parameter is they're looking for the average change in levels of all adult men. Okay. Not just the ones in the study. They're looking for the population is all of the men. 15, a researcher wants to determine the percentage given below. Describe how the researcher should apply the 5 basic steps. I'm going to just go through this one quick because all of these questions are very different and most of them you'll be able to work through pretty easily. But it says the percent, what it's asking is the percent of businesses that have over 20 employees. So determine how to apply the first basic step. And that is where you look at the population. So the population is all of the businesses. We're looking for what percent of all of the businesses. So we are going to go down here to the population is all businesses. The researcher wants to estimate the percent in this population that have over 20. This one is close, but it says that do not have over 20. So part C would be the answer to the first one. Determine how to apply the second step. So in step 2, the researcher should gather raw data. The researcher should only gather raw data. The researcher should gather data about having 20 employees from the largest sample of businesses from which they can. Seems like the right answer. The researcher should only gather raw data from businesses that have over 20. No, he's trying to compare all businesses together. So asking as many as they can is a good method. Part C, determine how to apply the third basic step. The sample statistic of interest is the number of businesses in the sample that have over 20. The sample of interest is the number of businesses in the sample that do not have. The sample is the percentage of businesses that have over 20, or the sample of interest is the percent of businesses in the sample that do not have over 20. So we're looking for the percent of businesses that do have over 20, not the number of businesses. We're looking for the percent, right? Okay, part 4. The researcher followed correct procedures. He or she can be confident that the sample statistic is equal to the percentage. If the percentage of businesses that have over 20 is greater than 50%, the researcher can be confident. As you read through these, D says the researcher should use the sample statistic as an estimate for the population value of all the businesses. Okay. Finding a certain percent doesn't guarantee anything. All that we can use is that sample statistic to make an estimate. Okay. And then determine the 5th step. The researcher knows the sample statistic is equal to the population. The researcher cannot draw any conclusion. The researcher should use the methods of statistics to determine the quality of the estimate. That sounds good to me. And draw conclusions based on the estimate accordingly. There's no way to determine how well the sample statistic estimates the population. That's not true. So we're going to stick with part C for that one. Okay. 16. Identify the sampling method as simple, random, systematic, convenience, or stratified. An IRS auditor randomly selects for audits 30 taxpayers in each of the categories. Right there gives you that each of the categories quickly tells you that you are looking at what are we looking at? This is I circled it already, the stratified, right? I'm looking here, and I started reading this line. So stratified is where they take one group, or they look at a sample from all the different groups, okay? They kind of break down the big population into subpopulations, and they look at each one of those. Okay, 7, identify the sampling method. Again, a college dean obtains an alphabetical list of full-time students and selects every 21st name on that list. So it doesn't sound stratified. It doesn't sound convenience. And it's not simple because they're selecting every 21st. So that's going to be systematic sampling. Okay. 18, a professor records the following grades in one course. Construct a frequency table. All right. To make the table, like we talked about before, it gives you the categories. You just have to fill it in. So a frequency wants to know how many A's do I have? So 1, 2, 3, 4, 5. 5 A's. 1, 2, 3, 4, 5. I got 6 B's. 1, 2, 3, 4, 5, 6, 7, 8 C's. I've got 4 D's and 1 F. Okay. So in total, that's 11, 19, 20. That's 24 people. All right, so we have 24 total people. The relative frequency means compared to all of the people, what is my percentage? So this would be 5 divided by 24. This would be 6 divided by 24, which is 25%. This is 8 divided by 24, which is 33.3%. It tells you to round to the nearest tenth. 4 divided by 24 is going to be what, 16.6. Oh, we're rounding, so 16.7%, I think. And 1 out of 24. So these two you can put in the calculator. I'm not going to take the time to do that in the video. Cumulative frequency. Remember, you add up all the categories as they go. So far we've had 5 people. When I get to B, I take the B's and I add the A's. So now there's 11. Now I add the C's, there's 19. Now I add the D's, there's 23. When I add in the F's, there's my 24. All right. So frequency table, I know I went fast and I'm not even going to do this one. If you want to see 19, go back and look at 18. But you are just taking the information and plugging it in. Okay. And it tells you a website reviews recent movie lists, 5-star films. Oh, there's 5 5-star films. So it tells you right here. There's 5 of them. There's 16 4-stars. There's 12 3s. There's 11 2s and 6 1s. So total, you would add those up. That gives you the total, and you use that to get the relative frequency. So this is what, 21, 33, 44. So that's 50. So this would be 5 out of 50. So that's going to be 10%. This is 16 out of 50. This is 12 out of 50, and so on. Okay. And then the cumulative, you add them up as you go. So this is 5 so far. 4 stars, we take the 4s and the 5s, add them together to get 21. We add the 12 now to get the 33, and so forth. Okay, number 20. Determine whether the following variable is qualitative or quantitative. The responses of customers on a satisfaction survey, I can tell you already that's going to be qualitative, because you can't measure satisfaction with a number. You can assign it a number like they did. 0 is a terrible satisfaction. 5 is fantastic. So even though we're assigning a number, the terrible and fantastic are not quantities. So we would choose that the variable is qualitative because our satisfaction is subjective. It can't be measured. Okay. All right, 21. Determine whether the following, and be careful here. C says it's qualitative because some customers will have biased opinions. That doesn't matter. That's not what makes something qualitative. Qualitative is something because you're not measuring it. It has nothing to do with bias. Okay, 21. Determine whether the following variable is qualitative or quantitative. Again, the flavors of ice cream sold at a, dude, how do you even read that word? Delicatessen? So again, the flavors is not something that you can measure. So it's not going to be quantitative. So it's either going to be qualitative because the flavors are non-numerical categories, or qualitative because how good the flavors are subjective. Well, we're not asking anything about how good they are. So we would choose option C. All right, moving on. 22, make a bar graph from the populations of the 5 most populous states. So you are going to, these are all kind of on top of each other. You're going to take this information and you're going to apply it to the correct bar graph. So when I look at this, A, B, C, D, and E, if I look at the populations, they actually go down in order, A, B, C, and E. So A should be the biggest and E should be the smallest. So that makes this one not an option, this one not an option, this one. Oh, actually, that one might be an option. Why did they not put it in order? That's silly. So then you look over here. These are both options, but you're looking for the one that is correct, okay? So I would choose this option, state A, B, C, D, and E, because our values are going to match up a little bit better, and they're putting them in order. So that looks like a better option to me. I'm sorry, they're kind of all on top of each other. On the homework assignment, the review, there's a little button that will let you click on it, and it'll actually blow up the image so that you can see it better. Anyway, oh, and right here, here's the other reason why we want D. It's a bar graph of the populations of the 5 most populous states in descending order. So it wants them going biggest to smallest. Anyway, moving on. Okay, number 23. Let's make sure we're still recording, shall we? All right. 23, use the given figure to complete parts A and B below. So briefly describe how the unemployment rate has changed with time over the period shown. So as I look at this, they're all going up and down, and they're all kind of following the same pattern, but they don't ever switch. This pink is always on top, the green's always second, the red's always third, the blue's always fourth, which is kind of what we expect. So when I look at these, I'm looking for something that says something similar to that, okay? The unemployment rate varies over the time period, so it goes up and down. The trend in differences between the educational attainment level has remained consistent. Yes, in that more education leads to smaller unemployment rate, since each year a higher level of education has, well, I love it when the first one is the right one. We can read through the other ones and make sure that makes sense and compare it, but everything in that one is true. The unemployment rate is clearly trending downward. No, it's not. It goes down and up and down and up and levels out. So that's obviously not right. The unemployment rate varies. The trend and difference between attainment level has changed. No, they're still the same. The pink's still on top, green second, red third, blue fourth. So not C, and D will say something similar to that, okay? B, for 2006, approximately how much more likely was a high school dropout to be unemployed than a worker with a bachelor's degree? So in 2006, we're comparing high school dropout with bachelor's. So 2006 is right here. High school dropout is the pink. So we're looking right there. And what was it? Bachelor's? Is that what we're comparing? Bachelor's is the blue one right here. So bachelor's looks like it's at about 3%, and not graduating looks like it's at about 6, maybe a little bit bigger. Please give me a drop-down menu. Don't make me guess something between double. Okay, there we go. Good. 2 to 3 times, 5 to 6 times, slightly, or 9 to 10 times greater. So we obviously want the 2 to 3 times. Okay, that's the one that we're looking for, because it's double, maybe a little bit more, but that's kind of the range there. Figure 5.31 uses a TV set to represent the number of homes with cable. Note that the heights of the TV represents the number of the homes. So this is going to be a perceptual distortion, because the height's going to change, but it's also going to change the width and the dimensions in 3D. So you're actually getting a three-dimensional, if not that, at least a two-dimensional perpetual distortion. And that makes it, remember, this is where they've gone from 23 to 108. That's a little more than 4 times as big. That TV is a lot more than 4 times as big. In fact, it's 16 times as big because it's 4 times as tall. Whoa, those are bad lines, Mr. Reed. It's 4 times as tall, but it's also 4 times as wide. So it's actually 16 times as big. And that's a frustrating distortion to look at. So I'm looking for something that describes that. The perpetual distortion is created because the area of the TV represents the number of homes, but the eye tends to focus on the volumes. Not exaggerating the true change to appear too small. It definitely doesn't appear to be too small. A perceptual distortion is created by the graphs. Since the scales vary between the two images, it exaggerates the true change. The scales don't, that's not our issue here. A perceptual distortion is created because the volume represents the number of homes, but the eye tends to focus on the areas. Nope. A perceptual distortion is created because the height of the TV represents the number of homes, but the eye tends to focus on the volumes. So it's even acknowledging the fact that this isn't just getting taller and wider, but it's also appearing to get deeper as well. So we would choose option D. All right, 25. The table shows the number of cell phone subscriptions. Display the data using an ordinary vertical scale and an exponential vertical scale. So ordinary vertical scale is, the table shows the number of cell phone subscriptions. So we are going to assume that cell phone subscriptions are going to go up. And again, these are kind of jumbled, laying on top of each other. But back here, it never goes down to 0. And I'm going to choose this one right here in the middle. And you'll be able to see that a lot better when you actually blow it up and look at the difference there. And then it wants the exponential vertical scale. So again, we know it's growing, but it's growing exponentially. So it's going to tend to look like it's flattening out, even though it's still growing. And so it's not going down. We know it's definitely not those two. So what we're looking at are these two graphs and which one's going to be the right one. And because I can't see the information the way it printed, option C is going to be our best option. And then moving on, which one is more useful and why? The graph in part A gives a better picture of the true nature. That's true. The graph in part B makes it easier to see the change in the late years. That's not true. The graph in part A gives a better picture of the true nature. The graph in part B makes it easier to see the changes in the early years. That sounds good to me. Part B makes it easy to see the change right here in the early years compared to this one where in the early years you can't really see what's going on. All right, moving on. Oh, there's the data. I was going to say they're just hoping that we can guess that it grows, but there's the data for the images. Okay, number 26, complete parts A through C for the time period shown in the accompanying figures. So here's figure 1 and figure 2, unfortunately, is going to be on, is right here on the next page. Okay, so in what academic year did public tuition rise by the largest percentage? And about what was that percentage? So we have two figures. This one is showing the percent change, and this one is showing the actual change. We actually used this example in our notes. So which one went up the most percent? Well, that's really easy to see. The biggest percent change is right here, and it looks like that's at about 13%, okay? And that is, does it ask for, nope, it asks for the year. So if I drop down, that's 2003, 2004. So 03 to 04, and it looks like it changed about 13%. And the year found in part A, about what was the percent in, oh, we just did that. The percentage increase in private college tuition was about what in that year? So in 2003, if I look at private college increase, which is this purple. So in that year, purple went up almost $5,000, just a little bit below 5,000. Oh, but it wants the percent increase. Sorry. 2003, 2004, private went up. Here's our private right here. So that gives us our 5%. It didn't want the actual amount right there. And then in the year found in part A, which had the larger increase in actual tuition, public or private colleges, explain, choose the correct answer. So in that year, which had the larger increase in actual tuition? So if I look at actual tuition, private went up, privates are blue bar, and it went up like $18,000, $17,000, and private or public only went up, we're right here at 2004. So 18,000 compared to like 5,000 in public. So we're looking for public college tuition rose more in terms of dollars. No, it didn't. Public college tuition rose more. No, it didn't. Private college tuition rose more in terms of dollars. Since their tuition was so much higher than public colleges, a lower percent increase on private college can be larger than a high percent increase on public tuition. Great answer. Private college tuition rose more since their percentage increase was higher. No, it wasn't. The percent increase was lower, but they started at a higher amount. So part C, or answer C, would be your best option there. Okay, 27, define and distinguish, ooh, fancy, among positive correlation, negative correlation, and no correlation. How do we determine the strength? Define positive. So remember, positive means when one grows, the other grows, or when one decreases, the other one also decreases. So positive correlation means that two variables tend to change in opposite directions. No, that's not true. Positive correlation means that there is a good relationship. No, it doesn't. Positive correlation means that both tend to increase or decrease together. Great answer. Negative correlation. Negative correlation means that two variables tend to change in the opposite direction. So while one variable is going up, the other one is going down. Okay. Define no correlation. So no correlation means there is no apparent relationship between the two variables. That seems like a good option. No correlation means they change in opposite directions. Nope. No correlation means the two variables are always zero. Nope. No correlation means that both variables tend to increase together. Nope. So it would be A. How do we determine the strength of a correlation? So the more closely, remember the strength is the closer they are together, the more straight that line is going to be. So the more closely two variables follow the general trend, the stronger the correlation. The more closely two variables follow the general trend, the weaker. No, A sounds good. The closer they follow that trend, the stronger the correlation. Let's make sure C and D aren't better. No correlation is stronger than negative correlation. Positive is stronger than no. No, that's not true. Negative is stronger than no correlation. Positive is stronger. Nope, that's not true either. So yeah, A is going to be our best option. That the closer they are to that trend, the closer the correlation is, the stronger the correlation is. Determine whether the statement makes sense or does not make sense. There is a strong negative correlation between the price of tickets and the number of tickets sold. This suggests that in order to sell a lot of tickets, the price should be lowered. So a strong negative means that as the price goes up, the ticket sales go down, or the other way around. Price goes down, sales go up. So that statement makes sense because if they want to sell a lot of tickets, they should have the price lower. So the statement makes sense. To increase ticket sales, the price should be decreased since there is a strong negative correlation. You can read these others to see why they don't make sense. I'm not going to read them to you. 29. Consider the scatter plot. State whether the diagram shows a positive correlation, negative, or no. So remember, positive is going up, negative is going down, no correlation is just all over the place. So if I look at this in general, it looks like it's going down. Okay. So I would say that's a pretty strong correlation. Those are, it's not like you have one here, one here, one here, one here, one here, one here, and it's going down. They're all grouped pretty close to a line. So I would say that is a strong negative correlation. It's going down, so it's a negative correlation, but they're close together, so it's strong. And if we're comparing the weight of cars and gas mileage, so heavier cars generally get higher gas mileage? No, they don't. Heavier cars get the same as lighter cars? No, they don't. Heavier cars get lower gas mileage. Yes, they do. And we'll cross out D. Okay, 30. For the following pair of variables, state the units that they may use to measure, then state whether you believe they are correlated. All right, so to measure or weight and how frequently a person attends rock concert. So to measure weight, we might use pounds. And it should give you, it does right here. Degrees, no. Liters, no. Feet per second, no. Pounds, yes. It'll give you a drop-down menu. To measure the frequency a person attends rock concerts, we're not going to use Fahrenheit. We're not going to use pounds or feet. We're going to count the number of attendances. What correlation, if any, is there between the two? There is a negative correlation because the weight of a person tends to increase. A person attending rock concert decreases. I don't think that's true. There's a positive correlation. The heavier someone gets, the more concerts they go to. I don't think that's true either. I would say that these variables are not correlated to each other. Okay, 31. Here's a table. Gives the average teacher's salary and the expenditure on public education per pupil for 10 places. Complete parts A through C. So it wants us to make a scatter plot. And as you look at these again, they kind of, remember, a scatter plot is one data point for each of these options. And all you have to do is match the data points to the diagram, which is hard to do when they're laying on top of each other. So if you're practicing this one, just look for the one that you're going to look to the left and the right. So for example, state A should have a teacher salary close to 50,000 and an expense close to 10. So if I'm looking at this diagram, the salary goes across the bottom and 50,000 is, see, I can't even tell where my 50,000 is. It starts at 20 and it ends at 80. So if this is my diagram right here, 50,000 is going to be right here somewhere. And I'm going to go up 10,000. So if this is 5,000 and it goes all the way up to 17, so this is 6, 7, 8, 9, 10. So I would expect there to be a point right there, which there is. Okay. And then it says to state whether the two variables appear to be co-related or not. Okay. Is that just part 2? Did we skip a part? I feel like we skipped a part. No, we didn't skip a part. But this A is not going to be the right one. D is going to be the right one. Sorry, I told you wrong. D is going to be the right graph that matches this picture. And then part B, do they appear to be correlated? If so, state if it's positive, negative, or not. The two variables appear to have a weak positive. The two variables appear to have a strong negative. The two variables to have a strong positive. If I look at my graph, it's going up and to the right. So it's definitely strong, or it's definitely positive. And we get a good run right here to kind of base our line off of. And yes, there's a few outliers, but in general, I would say that it's a strong positive correlation. Okay. Suggest a reason for the correlation. So states more focused on education are likely to pay teachers more and less likely to spend money on students. No. States more focused on ed are more likely to pay teachers more and spend more money. Yes. States more focused on ed are less likely to pay teachers more. Nope. Teacher salary and pupils' expenses are not related. Not true. Moving on, 32. We're almost done, guys. Consider the following statement about a correlation. State the correlation clearly. State whether it's likely due to a coincidence, a common underlying, or direct cause. Over the past 3 decades, the number of miles of freeways in LA have grown, and traffic congestion has gotten worse. So miles of freeway have gone up and traffic has gone up. So if I'm comparing miles to traffic, they are both going up together. So that's a positive correlation. Do we think, part A just wants to know, there is a positive correlation. They are both going up. Is it likely due to coincidence, a common underlying cause? So the fact that there's more freeways, does that cause there to be more traffic? No. The other way around, does more traffic cause more freeways? No. But I would say that there's a common underlying factor that there are more people in LA, and that's requiring more miles of freeway and more traffic. Okay, that would be my argument. So I wouldn't say there's no correlation. I would say that there is, but it's likely due to LA having a large population. There we go. That sounds good to me. Okay, 33, same idea. Over the past 30 years, data show that the number of games won by a Major League Baseball team increased with team payroll. So wins and money. It says that as one goes up, the other one goes up. Or at least that's what the data shows, that if the wins are higher, the pay is higher. So that is a positive correlation between a team's payroll and games won. This could be a direct cause, since a baseball team is likely to get paid more the better they do. That sounds okay. It's not negative. This is a coincidence, since a team's payroll will not change how good. Nope, that's not true. New York Yankees, what? We pay money for a good baseball team? Yeah, when you are the number one logo, the number one brand for baseball, you tend to have a lot of money to spend on good players. 34, consider the following statement. I didn't skip anything, did it? That was the whole question. Consider the following statement about a correlation. State clearly, if a correlation clearly exists, then state whether it is likely due to what? Automobile gas mileage decreases with tire pressure. So miles per gallon goes down as tire pressure goes down. So that is a negative correlation. That's a positive correlation because they're both going down, right? Am I reading this right? Auto gas mileage decreases with tire pressure. So yes, this is a negative or a positive correlation. As one goes up, the other goes up. As one goes down, the other goes down. So the correlation is due to first of all, positive correlation. And why? The correlation is due to a direct cause because more gasoline is needed to roll a tire with low pressure. That sounds okay. It's due to direct cause because there's no link. No. It's due to a common underlying cause because more gas is needed to roll a tire with lower pressure. That could be an option. Is that an underlying cause, or is one causing the other to happen? So right there, we've got to make a choice. Is one of these causing the other? So this one says that more gas is needed to roll a tire with low pressure. So if you think about a tire with low pressure, it gets flat at the bottom, and the car does have to work a lot harder. It's like have you ever tried to ride a bike with a flat tire? It is so much harder to ride than a blown up tire on a bike. So I would say it's a direct cause. I wouldn't say that there's an underlying issue for both. It's due to coincidence? No. It's due to a common underlying? No. There's no correlation? No. I would stick with A. That sounds like a good answer to me.